Welcome to the Greek Ship Corrosion channel. My name is احتشام زاده. I'm a researcher in the field of corrosion and protection of materials. Chapter 9, Section 6, Risk-Based Inspection. In this video, basics of risk-based inspection, COF and POF, the evolution of inspection intervals and due dates. The reference elements of a risk-based inspection program, API RP 580. Basics of risk-based inspection, consequence of failure and probability of failure for RBI according to API RP 580. The objective of RBI is to determine what loss of containment incident could occur and how likely the incident could occur. In determining the COF, the following are generally true. A. There may be one or more consequences from an event. B. Consequences are always negative for safety aspects. C. Consequences may be expressed qualitatively or quantitatively. For example, if a pressure vessel subject to a loss of containment event from corrosion under installation develops a leak, a variety of consequences should be considered. Some of the examples of possible COF events to consider are as follows. 1. Release of a flammable process fluid that could ignite, causing injury and equipment damage. 2. Leak of a fluid with release to environment without escalation. 3. Release of a toxic chemical that could cause injury or long-term health problems. 4. Release of a chemical that has an adverse economic impact. Or 5. Release of a chemical as a minor leak of non-flammable or non-toxic fluid that triggers other minimal safety, health, environmental, and/or economic impacts. Determining the POF. When determining the POF, the following are generally true. 1. The mathematical definition of probability is a real number in the scale 0 to 1 attached to a random event. 2. Probability can be related to a long-run relative frequency of occurrence or to a degree of belief that an event will occur. 3. Degrees of belief about probability can be chosen as classes or ranks such as rare, unlikely, moderate, likely, almost certain, or incredible, improbable, remote, occasional, probable, frequent. 4. Frequency rather than probability may be used in describing risk. 5. Probabilities may be expressed qualitatively or quantitatively. Staying with the CUI example from above, some of the possible probabilities of failure are as follows. A. Low, medium, high, etc. B. Occurs once every year in this facility. C. Occurs once every 10 years in this facility. D. Occurs 10 times every year in this facility. CUR or Controlled Unclassified Information refers to government-created or owned information that requires safeguarding and dissemination controls. It is identified through examples. Loss of containment may occur relatively frequently without significant adverse safety, environmental, or economic impact. Similarly, other failures have potentially serious impact, but if the POF of the incident is low, the risk may not warrant immediate or extensive action. However, if the loss of containment risk is high enough to be unacceptable, then the determination of the appropriate action to reduce the POF, for example, inspection activities and or repairs, and or the COF, for example, design upgrades of the event is appropriate. ISO risk plot. Understanding the two-dimensional aspect of risk provides insight into the use of risk for inspection prioritization and planning. POF and COF are plotted on an ISO risk plot or risk matrix to demonstrate the risk contribution. This figure displays an example of the risk associated with the operation of several equipment items in a process plant. In the example, the POF and COF have been determined for 10 equipment items, and the results have been plotted in an ISO risk plot. The numbered points represent the risk associated with each equipment item. Here the equipment number 1, 2, and 3 are beyond the ISO risk line. Risk equals probability times consequence. An ISO risk plot provides a basic visual guidance for a risk plot to demonstrate that 1. Ordering by risk from high POF, high COF to low POF, low COF produces a risk-based ranking of the equipment items to be inspected. From this list, a risk-based management plan can be developed that focuses attention on the areas of highest risk. 2. An ISO risk line is also depicted on this figure. An ISO risk line represents a constant risk level as shown across the ISO risk plot. 2a. All items that fall on or very near the ISO risk line illustrates that all of the different combinations of POF and COF on that line are roughly equivalent in risk, even though the level of POF and COF can vary widely. 2.2. A user-defined acceptable risk level could be plotted as an ISO risk line. In this way, the acceptable risk line would separate the unacceptable from the acceptable risk items. 3. Due to the nature of the magnitude differences along each axis, a risk plot is often drawn using logarithm scales for a better understanding of the relative risks of all the items assessed. The evolution of inspection intervals and due dates. In process plants, inspection and testing programs and process monitoring are established to detect and evaluate equipment deterioration due to the effects of in-service operation. The effectiveness of inspection programs varies widely, ranging from reactive programs, which concentrate on known areas of concern, to broad proactive programs covering a variety of equipment. One extreme of this would be the "don't fix it unless it's broken" approach. The other extreme is complete inspection of all equipment items on a frequent basis. Setting the intervals due dates between inspections has evolved over time. With the need to periodically verify equipment integrity, organizations initially resorted to time-based or calendar-based intervals due dates. With advances in inspection approaches and better understanding of the type and rate of deterioration, inspection intervals due dates became more dependent on the equipment condition, that is, condition-based inspection, rather than what might have been an arbitrary calendar date. Codes and standards such as API 510, API 570, and API 653 evolved to an inspection philosophy with attributes such as: A. inspection intervals due dates based on some percentage of equipment life, such as half-life calculations. B. On-stream inspection in lieu of internal inspection. C. Internal inspection requirements for damage mechanisms related to process environment-induced cracking. And D. Consequence-based inspection intervals due dates. RBI represents a methodology that combines the probability of a loss of containment event and the resulting consequence. This combination represents the risk to a facility due to loss of containment. This risk value is used in setting specific inspection approaches and due dates to help achieve safe and reliable operating facilities. RBI as a risk-based approach focuses attention specifically on the equipment and associated damage mechanisms representing the most risk to the facility. In focusing on risk and its mitigation, RBI provides a better linkage between the mechanisms that lead to equipment failure, loss of containment, and the inspection approaches that will effectively reduce the associated risks. There are many industry definitions for failure of pressure equipment, but in this document, failure is defined as loss of containment. Challenge number 44. Thank you for your time and attention. If you like to challenge yourself, please answer these questions in the comments below. 1. What is an API 510 inspector responsible for? 2. What does an API 570 inspector do? 3. What's the difference between API 510 and API 570? 4. What does an API 653 inspector do?